This coordinate plane shows a single straight line. In algebra, we can express the relationship between x and y using 3 different mathematical languages: slope-intercept, point-slope, and standard form. The one we choose depends entirely on the specific information provided in the problem. Slope-intercept form is often the most direct path when a line crosses the y-axis at a clearly defined point. On this graph, the y-intercept, our c value, is exactly 5. Next, we find the gradient by calculating the rise over the run between our intercept and the next clean coordinate at 4, 2. The line drops by 3 units for every 4 units it moves to the right, giving us a gradient, or m, of -3/4. By substituting the gradient and the intercept into the formula y equals mx plus c, we get y equals -3/4 x plus 5. This completes our first language, slope-intercept form. This method is highly intuitive, but it is limited by its total reliance on a visible, perfectly clean y-intercept. Without that specific point, we need a more flexible approach. If the y-axis is hidden or the intercept is a messy fraction, we shift to the point-slope formula. This allows us to define the line using only the gradient and one known coordinate, like our point at 4, 2. In this formula, m remains the gradient, while x1 and y1 represent the x and y values of our specific coordinate. We substitute -3/4 for the gradient, 4 for x1, and 2 for y1. This results in the equation y minus 2 equals -3/4 times the quantity x minus 4. Point-slope form is a highly efficient tool for calculation. It allows you to build a mathematically accurate equation from minimal data, without the extra step of solving for a missing intercept. Many exams will require you to provide a final answer in standard form. This requires all terms to be on one side, set to 0, and written as whole integers. To reach this format, we start with algebra. Pause here and try expanding the bracket on the right side by distributing the fractional gradient. Distributing the -3/4 gives us -3/4 x plus 3, since multiplying two negatives results in a positive. Now we move every term to the left side. As each term crosses the equal sign, the signs reverse, leaving us with 3/4 x plus y minus 5 equals 0. To satisfy the integer requirement, we multiply the entire equation by the denominator, 4. This clears the fraction and gives us our final result, 3x plus 4y minus 20 equals 0. Standard form creates a uniform, clean equation. By removing fractions and gathering terms, it provides a consistent format that is easy to compare and evaluate. At first glance, these equations appear to describe different lines. Standard form has no obvious connection to our initial equation. However, isolating y in standard form leads straight back to y equals -3/4 x plus 5. Every one of these equations describes the exact same set of points on the graph. Use slope-intercept when you have a clear y-intercept, point-slope when you have a gradient and a random coordinate, and standard form when a problem requires final integer values. Mastering linear equations is about choosing the most efficient format for the variables at hand. With these 3 tools, you can accurately describe any line, regardless of the information you start with.